Hello everyone, welcome to SCI-EASE. In this video, I am going to start with the new chapter of class 10 and the name of the chapter is Periodic Classification of Elements. You know that nowadays we study modern periodic table and it has approximately 118 elements. And these elements, they are arranged in groups and periods. But in the 18th century, only 30 elements they were discovered. To begin with, how these elements should be arranged, what should be the order, scientists, chemists, they were busy in doing this. So, first thing, we should find the answer for this question, why we need to classify the elements. Whenever you visit some confectionery shop, you see that all shampoos, all soaps, then biscuits, namkeens, they are arranged properly. Okay? They are arranged properly so that there is no chaos. You want Dettol soap or Dove soap, or you want Dove shampoo or Head and Shoulder shampoo, you go to that rack and pick that one by one. So nothing difficult that is there. Everything is so easy. And you pick up the things and you buy the grocery or some confectionery items. Okay. So, likewise, scientists or the chemists, they also want that they should arrange these elements in some order. What do you mean by this order? That they should resemble in their properties. Okay, so in 18th century, 1817, there was one chemist, German chemist named Dobereiner. He was a chemist, okay. He found that these 30 elements, out of these 30 elements, he arranged 9 elements in the form of triads. What do you mean by triad? Triad means a group of 3. Okay. So, we will study prior to this modern periodic table, 3 tables given by different chemists or the scientists. They are Dobereiner triad, Newlands law of octave, Mendeleev's periodic table. Okay. So, in this video, I will take up the first 2 At this time, Dobereiner tried 30 elements they were discovered. Out of these 30 elements, he formed 3 triads. Okay, means for 9 elements, he formed the triad, that is a group of 3. And what he concluded from that the atomic mass of the middle element in the triad, it is equal to the average of first and third. Okay, so the first triad, that is lithium, sodium, potassium, then calcium, strontium, barium, and chlorine, bromine, iodine. And you will see that the same sequence is there in the modern periodic table. This means he has contributed a lot. Okay? कुछ भी हमने शुरू करना होता है तो उसमें बहुत एफर्ट लगती है. ठीक है? हमें बना बनाया अब सब कुछ मिल गया. We are to remember the periodic table और कुछ ऐसा हमारे लिए इतना नहीं रह जाता. बट जो साइंटिस्ट इनको टू बिगिन विद ढूंढते हैं, ठीक है, उनके लिए ये कितना चैलेंजिंग काम है, कितनी चैलेंजिंग जॉब है. सो व्हाट ही सेड दैट द एटॉमिक मास ऑफ this triad sodium, for the first triad, atomic mass of sodium is equal to the average of the atomic mass of lithium and potassium. So we will do this. Lithium has atomic mass 7, potassium 39. So the average of 7 plus 39 by 2, it is equal to 46 by 2. So it is 23. Actually, the atomic mass of sodium is 23. Now next triad is calcium, strontium, barium. So calcium, what is the atomic mass of calcium? It is 40, barium 137. So what will be the atomic mass? It will of strontium, it will be 40 plus 137 by 2. It will come out to be 88.5. Okay. Now next triad, that is chlorine, bromine, iodine. In the actual periodic table, you will see modern periodic table, you will see that all the sequences, they are there. Okay. So chlorine, bromine, iodine. Chlorine has atomic mass 35.5. Okay. Bromine, we are to find out. And iodine, it is 127. So 35.5 plus 127 divided by 2. What you will get, you will write in the comment section. That will be the atomic mass of bromine. Okay. So, Dobereiner, he arranged the elements in the form of triad, group of 3. So, he could arrange only the 9 elements in the form of 3 triads, and at that time, 30 elements, they were already discovered. So, there are some of the, you can say, limitations also. So, what is his contribution? Arranged elements in order of their increasing atomic masses. It has less than increasing atomic masses. Atomic mass of the middle element is the average of the atomic mass of the first and the last element. This much he has told. Okay. What was the limitation? He could arrange only the 9 elements in the form of the triads out of 30 elements existing during his time. Okay. So this is, I think, Dobereiner triad, that is clear to all of you. Okay. Now I will tell you about the Newlands law of octave. This one is Newlands law of octave. At that time, when Newland, he arranged the elements in particular order, there were 58 elements discovered. Okay. So, he arranged the elements like this: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. He arranged them in increasing atomic masses. Okay. So, hydrogen, lithium, beryllium. Here, the atomic masses, they are increasing. Okay. And the other thing, he told that every 8th element that shows the same property as the first one. Okay. Means fluorine has the same property as hydrogen. Chlorine has the same property as that of fluorine. Okay. So, he arranged the elements in increasing order of their atomic masses. And second thing, he told Newland's law of octave. What do you mean by octave? After every 8. Okay? So, the physical and the chemical property of the element that is repeated after every 8th element. Okay? So, hydrogen, fluorine, chlorine, they have the same properties. They have same physical and chemical properties. He matched this with the Sare Gama Pada Nisa. In music, we have these notes, that is Sa Re Ga Ma Pa Da Ni Sa. Again, Sa Re Ga Ma Pa Da Ni Sa. Okay? So, first element, suppose first element is this, and 8th element, that is again Sa. It has a same property. He took this into consideration. That is why he gave this law that every 8th element, it resembles the first one. Okay? So, but he could arrange the elements, this periodic table, that is applicable only till calcium. Okay? Only till calcium, he can arrange this. And second one, in his periodic table, he placed 2 elements in the same group, which is not possible. Like cerium and lanthanum, in the same group he has placed. So that is not possible. And the third drawback is, he could not give spaces for the newly discovered elements. He thought कि बस इसके बाद कोई element discover ही नहीं होगा, which was not possible. Today we know that 118 elements are there in the periodic table, and at that time only 58 elements were there. So he has not given the spaces for the newly discovered elements. So I think these 2 periodic tables, that is Dobereiner's Triad and Newland's law of octave, that is clear to all of you. In my next video, I will take up Mendeleev's periodic table. Till then, thank you very much.